Okay, so good morning. We are Friday, July 14th. Um, and so we have completed 2 weeks so far, which is absolutely fantastic. You guys are doing really well. I'm proud of each and every one of you. And so we are looking at transformations for exponential and log functions. And so I'm gonna share my screen here. So don't forget that you do have quiz number 5 that's due today. And you've got another lesson. It's not done by me. There's not many that have to be done by me. There's actually only 5 that I can see. And so you won't get to see this cute avatar all too much. Nice. I forgot to put the quiz in. Okay, so I'm gonna do that. I'm gonna actually highlight it as we speak so I don't forget. Okay, so we're looking at transformations of log and exponential functions. So we've got properties of exponential functions. So the general equation is a times b to the exponent k times x minus d, and then plus c. So where the base function is b to the exponent x. Okay, there are 4 possible shapes for exponential function. So when a is larger than 0 and b is larger than 1. So for example, we've got y is equal to 2 to the exponent x. And so this is what your function looks like. So it's all color coded for you. When a is larger than 0, but b is between 0 and 1. So when we've got 1 over 2 to the exponent x, it goes this way. We've got when a is smaller than 0, so we've got a negative, and b is larger than 1. So for example, -1 times 2 to the exponent x. It's the same thing, it's just going downwards. So we've seen that in our transformations with quadratics, right? It just does a reflection on the x-axis. And then we've got our orange line. So that's when a is smaller than 1 and b is between 0 and 1. So that's your -1/2 to the exponent x. Of course, my dog's walking around like a hooligan. So to graph the base function y equals b to the exponent x, find the following key features. So you have to find your horizontal asymptote. So starts at y equals 0 and can be shifted by c. We're obviously going to do some examples. So find your y-intercept. So set x to 0 and solve. And then at least one other point to be sure of the shape. So common to choose is x equals to 1 and solve for y. Okay. So you can then use transformational properties of a, k, d, and c to graph a transformed function. So I'm going to get my pen. So it's asking you to sketch a few different graphs. So our starting graph, our base graph is 3 to the exponent. Oh no. All right, so I'm going to pause this and figure this whole thing out. Okay, so hopefully this is working now. I never used to have issues with it until this summer, which is a pain in my butt. Okay, nice. So we're going to use the x values of -1, 1, and we're going to put our horizontal asymptote here. So 3 to the exponent -1 is 1 over 3, which is 0.33. Anything to the exponent 0 is 1, and 3 to the exponent 1 is 3. And our horizontal asymptote is y is equal to 0. Okay, we're gonna do the same thing here. So what you're gonna do is 2y minus 5. Okay, so if your exponent is -5, so that's just taking into account all of this. Your horizontal asymptote, okay, this is supposed to be a plus. So you throw in -5 here, so you'll do 2 times 3, or 3 to the exponent 5, -5. My goodness. 3 to the -5 times 2 minus 5 will be -4.33. This will be -3. This will be 1. And our asymptote is -5. So that's this number at the end. Same with this guy. Okay. So you're going to do the same thing here. So if our exponent is -2, 0, 2, so -3y plus 4, that'll give you 3.67, 3, and 1. I am going to have to clear those numbers just so I can get to the graph. Okay, and so I'm going to use 3 different colors. So I'm going to start with red as our base function. So our base function has the horizontal asymptote of 0. And so and it goes, and it crosses here, and it just keeps going. Okay, and this is y is equal to 3x. So if you were to do it another way, your numbers, you would throw in your numbers here. So the numbers that you had found there in your table of values. And then we're going to find g of x, where we found that the horizontal asymptote was -5. Okay, so this is our asymptote that is beautifully drawn by your very own teacher. And so that means it follows it and it will never stop. If you were to put your points in, I'm just making sure my points are good here, there. And then at -3, it's here. Obviously, it's a lot easier to do on a paper. And it goes on and on, okay? And so this is our f of x. And then we've got our g of x that uses the asymptote +4. So beep, 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 beep. And it goes on and on and on. Okay. So it crosses here and it follows your asymptote. And it goes like that. Okay. So if you just put your points of your table of values, obviously it's going to be a lot better drawn than mine. So I am going to clear this so I can move forward. Okay, so we've got properties of logarithm functions. So you've got your general equation of a log to the base b k times x minus d plus c, where the base function is log of bx. So remember that log of bx is the inverse of the exponential function bx. So there are 4 possible shapes for the logarithmic function. So when your k is larger than 0 and b is larger than 1. Okay, so that's your red line there. When your k is above 0 and b is between 0 and 1, so that would be your green. So it's the same thing, it's just going into the opposite direction. When k is higher or bigger than 0 or smaller than 0 and b is larger than 1. So that's your blue one, it'll be on the opposite side, and then same with the yellow one. So to graph the base function of log bx, find the following key features. So you have to find your vertical asymptote. So start at x equals 0, and it can be shifted by d. So your d would be this number here. You want to find your x-intercept. So set 0 or y equals 0 and solve, and find at least one other point to be sure of the shape. So commonly choose is 1. Okay, so we're going to do an example. I'm just going to, yeah, I can't do that. Okay. So we're going to do the same thing. You do your table of values and then you're going to draw it. And so when x is equal to, or when y is equal to -1, your vertical asymptote is 0. So your x is 3. You might find a pattern here that we've seen earlier. Okay. So this just means you're putting -1 where the y is, and then you're solving for x, and it gives you this. So same thing with this guy. We've got our x here. You're going to do -4y plus 2. Equal to 6, 2. So I'm just doing this quickly. Hopefully you understand and know what to do. If not, just message me. I can slow it down. Okay. Negative x minus 2, and then you've got y minus 4. So when this is equal to 2.33, -3, -5. Your VA is x equals -2. Wow, I really missed that one, eh? So I'm not going to draw it out for you. You just got to put your points in, make sure you've got your vertical asymptote in there, and you should be good. Okay. So sorry to kind of speed those things up. We're done with this unit after your next lesson, which is the natural log. So that's looking at like real life problems. So one of my favorite ones was like, when I had done it, we did like a CSI kind of thing, which is pretty cool. But unfortunately we don't have time. So yeah, good luck. And happy Friday. I hope you guys have a great weekend.